Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and in this series of our discussion on this topic surfaces in sequence stratigraphy. So, in this class also we will continue with that series and we will discuss about another very important surface in sequence stratigraphy. That surface is called as transgressive refinement surface. This is abbreviated as TRS, transgressive refinement surface. So, a refinement process or a refinement surface, it is commonly an erosional surface which forms during transgression. That is why the name is transgressive refinement surface. Now, the question here is, what is the meaning of this term refinement? So, refinement, as per the information available, a refinement indicates formation of some ravines, that means some irregular junction which marks a break in the sedimentation. And when it is a transgression, then commonly that kind of refinement is in general marked by some sort of erosions caused by the incoming water body during the transgression. So, in sequence stratigraphy, as in our earlier class we have seen that refinement surface can form at different phases. So, whenever we are getting an erosional surface, that can be called as a refinement surface, but during transgression we get this erosional surface, which is important. So, this transgressive refinement surface or the refinement associated with transgression which is producing a particular surface is very important, and we will try to understand that what are the different types of these transgressive refinement surface and how they can be recognized. So, these are the surfaces or a single surface. Normally, there are multiple surfaces formed at different times at different parts of the basin. So, these are commonly the scours cut by normal marine processes. What are those normal marine processes? It can be either tide or it can be wave. So, scours can be formed by tides or waves. So, definitely this should take place near to the shoreline, close to the shoreline in the shallow marine part. So, in the deep marine part, we cannot expect the scouring by these processes, and that is why we cannot identify the transgressive refinement surface in relatively deeper part of the basin. So, these are associated with transgression in the basin. As the transgression starts and on the earlier low stand deposits, the transgressive marine deposits that encroaches. So, when that kind of encroachment, that kind of onlap occurs due to increasing energy of waves and tides, we can expect this kind of scouring. So, these scoured surfaces are commonly superimposed and onlapped by the transgressive deposits which are coming after that erosional process, which are getting deposited after that erosional process. So, commonly they are shore face deposits or they can be other deposits like even self deposits. So, they can come over this particular surface, this erosional surface, and that is also a very important parameter, important aspect for the identification of this kind of surface. So, based on the agent, based on the type of erosion, type of scouring, who is responsible for this scouring, we can identify two different types of transgressive refinement surfaces. One is called as wave refinement surface, it is abbreviated as WRS, wave refinement surface, and the second one is again called as TRS, tide refinement surface or tidal refinement surface. So, based on the dominant agent which is responsible, it can be either a wave refinement surface or it can be a tidal refinement surface or tide refinement surface. In the marginal marine part of the basin, we can identify both of them, a tidal refinement surface as well as wave refinement surface, or in many cases, particularly when the tidal effect is relatively less, or it gets overprinted by the wave activities, in such cases very prominently we get preservation of this wave refinement surface. And that is why many times this transgressive refinement process is often considered as nearly equivalent to the wave refinement process during transgression. So, in this class we will try to understand that what are the different aspects of these two types of surfaces, wave refinement surface and tide refinement surface. So, if I want to understand now that what actually is the meaning of transgressive refinement surface within a sequence stratigraphic framework, so this we can understand using a simple diagram. We can draw that diagram to understand how this kind of refinement surface forms and where this kind of refinement surface forms. Let us take an example, say this is the fluvial part, this is the shoreline, and from the shoreline we are getting the marine part. And on this marine part, let us say this is the LST deposit. So, this is the fluvial LST deposit in this area. Then in this part we get a delta formed over here, which is formed by progradation of the fluvial system, and then this is the LST part of the marine, which may include the shore face deposit, or somewhere here it may be the self deposit. When this LST was forming, at this point the base level was somewhere here. Now, from this base level position, as we know during the transgression, the base level starts rising. So, the base level is rising up now, and due to that rise in this area, earlier the wave erosions, wave reworkings were confined over here under this particular base level condition. Now, as the sea level is rising up over here, this energy condition is shifting at this point, and as a result now we are getting a new wave reworking process going on in this area. But remember, by the time when this rise is going on and the sea level is trying to encroach towards the land, this fluvial system is supplying the sediments, and those sediments are coming up over here and they are trying to accumulate. So, during this accumulation process, initially at the first phase of transgression we get some phase of depositions, but those deposits tries to onlap as the sea level is rising up, and as the sea level is rising up over here, so we get this erosional effect by the wave and the tidal current which is operating in this part of the basin. So, what will happen now? In this part, these accumulated sediments will be removed. Now, whether it will be partially removal or it will be entire removal, that will depend on how much sediment is coming into the system and how much sediment is accumulating into the system. So, what will happen over here when this kind of erosion will continue? So, initially we can expect a surface formed over here which is an erosional surface, as the wave reworking is going on over here at that time. Now, the sea level is rising up over here, and for that purpose now the wave reworking is going on over here and sediments are still coming in, and we are getting a new surface formed over here, another wave refinement surface. So, as this sea level will rise and it will try to encroach into the land, the shoreline will try to shift towards the land, we will get this wave refinement process, wave refinement surface shifting towards the land, depending on where exactly this erosion is going on. In the same way as wave reworking is going on, similarly tidal reworking will be going on. Normally tidal reworking goes on more near to the shoreline. So, the tidal reworking will be somewhere here in this part for the same wave reworking going on over here. So, in this diagram, if I draw the wave reworking going on somewhere here, the tidal reworking will be going on somewhere here, and we can identify the tidal refinement surface formed in this part, whereas the wave refinement surface formed over here. So, definitely in this kind of scenario, as when the erosion is going on this surface nothing is deposited, because erosion is going on now. But below this, what we can expect, some part of the TST, the very early phase of the transgressive deposits, they will get deposited over here in this part. So, those deposits will underlie these surfaces. So, a transgressive refinement surface will be always identified or it can be recognized in the marginal part of the basin where this wave reworking is going on, where tidal effects are very strong. If we move into the deeper part, say for example, here it is the self area, we can get in the self area only very rarely some storms, which if is associated with the transgression, then only in the self area we can expect some sort of erosions by the storm waves. But again, by the time in the last class we discussed about condensed section. So, when this kind of high water level is there, we expect formation of condensed sections over here in these portions, and these are mud dominated. So, even it becomes very difficult for storm waves to erode these surfaces. So, very rarely in the self environment or in the deeper part of the basin, we expect formation of transgressive refinement surfaces. They will be confined only in the marginal part of the basin, where we get a transition from fluvial to marginal marine to the marginal shallow marine part. In this kind of scenario, we can expect formation of a transgressive refinement surface. So, when this kind of transgressive scours one after another forming and finally they are amalgamating, they commonly form in the open shoreline settings. So, such amalgamated transgressive scour lines, scour surfaces, if we can found in the open shoreline settings, they commonly separate the transgressive beach deposits which are lying below, the onlapping beach deposits which are lying below, and the overlying shore face deposits which are formed after the transgressive or during the late phase of the transgression. So, definitely in this diagram, when the erosional effect is gone, say this surface has formed, which is a, say for example, this is a WRS surface, wave refinement surface, but the transgression is going on, the base level is very high. So, at that time when this erosional effect is gone, we will get deposition and those deposits will be onlapping. What are the deposits? This may be the shore face deposit. So, shore face deposits will be onlapping onto the foreshore deposits, maybe onto the backshore deposits, or maybe into the deltaic part forming an estuary. So, they will be onlapping estuary deposits. Sometime from the much deeper part, self-hull area, deposits may come over here and can onlap. So, we can get self deposits overlying the underlying units. Now, what are these underlying units below this particular surface? These are dominantly the beach deposits. Now, what is this beach deposits? That includes the shore environments. So, it can be foreshore, it can be shore face, it can be the backshore. So, commonly those deposits are onlapped by the late phase transgressive deposits, which will onlap along this particular surface, which marks a break, which marks a drastic changeover with respect to the facies types underlying and overlying this particular surface. So, these transgressive scour surfaces, they are commonly associated with or they separate the backstepping transgressive beach deposits below and the transgressive shore face strata above this particular surface, particularly when the retrograding facies are preserved, all the retrograding facies types are preserved along this particular surface. So, depending on the amount of refinement, how much refinement has taken place, how much scouring has taken place. So, the underlying unit, whether it is the beach deposits or it will go further down and it will reach up to the underlying FSST deposits, it may vary, because how much erosion is going on during this transgressive refinement process, it will entirely depend on the energy condition of the waves and the tides. So, it may happen that in different parts of the basin, we can get different types of facies underlying this particular surface, and also from area to area, we can get different types of facies depending on how much erosion is going on in different parts. Let us try to understand this with another example. Say for example, over here if I look at here, in this part the underlying unit is a fluvial unit, as I have marked over here. There is a fluvial low stand deposit. So, when tidal ravinement will go on and a tidal ravinement surface will form, the underlying unit will be a fluvial facies which has formed during the earlier LST, followed by initial fluvial deposit which was transgressive and which was onlapping, maybe forming a part of estuary in some portion, and this is now eroded, and on this erosional surface maybe the shore deposits are coming over. So, in this kind of cases we can get an estuary at the underlying facies, we can get a fluvial deposit as the underlying facies. Whereas, if we look at somewhere here in this part, or if we look at somewhere here in this portion, what we are getting, the underlying facies is already a shore deposit which is overlain by this erosional surface, and on this erosional surface onlapping units are either shore face deposits or self deposits. So, in this kind of cases the underlying unit, facies assemblage is a shore facies assemblage, whereas in this case the underlying facies assemblage was a fluvial facies assemblage or maybe an estuary facies assemblage. So, in which part of the basin this erosion is going on, this covering is taking place, that will determine what will be the underlying facies and what will be the overlying facies. Not only that, it may also happen that the erosion going on over here, it goes on at such extent, there is a huge amount of erosion is going on, and as a result this LST is entirely removed and it reaches up to the underlying subaerial unconformity surface. So, in such cases the underlying unit will be the FSST deposit which has formed much earlier, but now these are amalgamated, these are juxtaposed. So, the underlying facies across a particular ravinement surface, a transgressive ravinement surface, that can vary enormously. It will depend on the amount of ravinement scouring. So, it can be beach sediments, it can be underlying fluvial transgressive facies which may be preserved, may not be preserved depending on how much erosion is going on, and the transgressive ravinement surface may truncate the older normal regressive strata. So, it can definitely penetrate the low stand systems tract, or even if there is an unconformity, it will merge with unconformity, and even it can go down to the earlier high stand strata, and depending on that the underlying facies types, underlying depositional systems will vary. So, it is very difficult to fix the type of depositional system that will underlie a transgressive ravinement surface. So, for these reasons the facies found below a particular transgressive ravinement surface are variable. So, they can vary from fluvial system to coastal system to shallow marine system. However, above the surface commonly, as it is a onlap is going on, continuous onlap is going on, and the marine system is gradually shifting over the continental system. So, above this particular surface we expect always a shallow marine deposits which may vary from shore facies to self facies. So, transgressive ravinement surface, they are characteristic in this particular point, from this point of view, that the underlying facies can be extremely variable. We will get them in the marginal marine part of the basin only, and where the underlying facies can be extremely variable, but the overlying facies would be always an onlapping shallow marine deposit. So, that is the characteristic of transgressive ravinement surface. Particularly if we look into the river mouth area, which is a very important area to identify or demarcate the ravinement surfaces, because there we get a very complex interplay of river, wave and tidal processes. which results in the formation of delta, or an estuary depending on whether it is a regressive condition or a transgressive condition. So, when we look into the river mouth setting, and if it is a transgressive condition, we expect an estuary to form over there. So, it can be either a wave dominated estuary or it can be a tide dominated estuary. So, in either of the cases, depending on the relative strength of tide or wave, whether it is a tide dominated condition or whether it is a wave dominated condition, depending on that, we can identify a tidal ravinement surface and wave ravinement surface. The interesting fact over here is whether it is a tide dominated estuary or whether it is a wave dominated estuary, in both the cases we can identify these two surfaces separately, a tidal ravinement surface and a wave ravinement surface. They can be identified separately. So, they may be preserved in this kind of river mouth settings. They can be preserved as distinct surface having distinct scoured contacts separated by the sandy deposits of the estuary mouth complex, where very clearly, very distinctly we can identify the overlying and the underlying units, and in such cases identification of the transgressive ravinement surface can be done in the best way. So, with a simple diagram we can try to understand that what are the scenario. So, first we discuss about wave dominated estuary setting. So, to understand this, first we have to look at how a wave dominated estuary looks like. So, maybe it is a river system. So, this river system, say this is the coastline. So, from here we get an opening, funnel like opening, which actually forms the estuary. Now, within this funnel like opening, if it is a wave dominated condition, we get the river mouth area, and that river mouth area is commonly associated with some barrier bars, which are dominantly sand dominated or sand depositing condition. So, maybe another barrier bar over here. So, these barrier bars act as the barrier for the wave to come in. So, this is the river system which is flowing in this direction, and due to this river system we are getting a mix up over here in terms of incoming tidal water and the river water. As a result of that, what is happening in this area, this entire portion, it is becoming kind of water locked area, a kind of low energy zone, which commonly we call as the central estuary, which acts like a lagoon. Now, within this lagoonal system, what are the effects in terms of this ravinement process? Here the waves are coming from this direction towards the coast, and they will be buffered over here along these barrier bars, as wave cannot propagate into the fluvial system, they cannot propagate into the land part. So, they will be buffered over here. So, definitely this particular area will act as the erosional surface produced by the waves. So, we can identify the wave ravinement surface somewhere along this zone, along the mouth bars at the estuary mouth, outer estuary part. Now, along with this, definitely some tides will be acting, and those tides will use these gaps as the conduit, as the channel to come inside this zone. So, for the tides, what will happen? Tides are currents, flood current and ebb current. So, tidal currents, particularly the flood current, will try to encroach over here using this channel, and it will try to go inside towards the river, towards the continental side, but it will be obstructed by the water body which is already standing over there. So, as a result, what will happen? We get a zone of interaction up to which the tidal effect will be maximum, maybe something like this. We can get a delta formed over here by tidal washover deposits, some localized delta formed over here, some interdistributary bays formed over here. So, these are the different type of sub environments, different type of conditions that will develop over here. But importantly, in this area the tidal current will be dominant along this zone, That means the tidal erosions, tidal covering as the system is moving in and this estuary is forming, tidal erosions will be confined along this particular line. So, the maximum extent of tidal refinement surface can be somewhere here. These are the lagoonal part. So, definitely when this system will be moving in gradually, it is an onlapping system. So, on the fluvial system gradually the marine system is trying to come up, it is trying to onlap. So, these outer portions will try to gradually cover up over here, try to come up over here. So, what will happen in such cases? The tidal refinement surface, it will be overlying the fine grained sediments that will be deposited within this lagoon. So, it will be very easy to identify the tidal refinement surface in this kind of scenario. If we look at this landward side, there we get another delta formed over here, which we commonly call as the bay head delta. So, a bay head delta will form over here, a lagoon will form over here, and a tidal refinement surface will form at the top of these lagoonal deposits, which will be overlying that unit. The marine sediments, tide led sediments, so forming some sort of bars by tidal currents, they can form above this. In this kind of wave dominated estuarine setting, we can distinguish the wave refinement surface and the tide refinement surface separately, as they will be forming in two different zones, in two different areas. And definitely the sediments underlying and overlying these two surfaces will be distinctly different. What will be the case if we look at the tide dominated estuarine setting? In tide dominated estuarine setting, the scenario is little bit different. Let us think of a river system which is a meandering river. Say if this is the shoreline, then this river is opening up the funnel system like this. So, the shape of this estuary is completely different from a wave dominated estuary. So, in this case it is tide dominated, so tidal currents can come in, and it is not wave dominated. So, normally these are macro tidal conditions. So, in such conditions the waves are commonly confined over here, more towards the shoreward side. So, definitely the wave refinement process will be confined somewhere here, it will not go much inside, because in this portion it will be buffered by multiple bars, commonly the tidal bars. Multiple this kind of bars formed along this river mouth area, estuary mouth area, and they will buffer the wave to come towards the shoreline. So, definitely the wave refinement surface will be much away from the actual shoreline in this particular area. And then what about the tidal current? It is getting obstructed by the river system, river water. So, we will get a zone somewhere here which will mark this interaction of tide and the river, and due to this interaction the tidal current will lose its energy drastically. So, again we can think of a surface somewhere in between where we get the maximum energy of the tidal current. After that the energy of the tidal current will drastically get reduced. So, in this kind of scenario what we will get, this portion which is the central estuary part is actually affected by tidal currents and the river currents. So, what we get over here, we commonly expect formation of multiple channel bars, which are nothing but the manifestation of tidal and fluvial interactions. We can expect formation of tidal flats along these boundaries, where we can get a gradual shift from relatively high energy tidal condition to completely low energy tidal condition. So, a kind of changeover from sand flat to mud flat type of condition, same along this bank, and in between these we get this refinement caused by tidal processes. So, this is the tidal refinement process or tidal refinement surface. So, again in this case when we are looking at a tidal refinement surface, that can be completely distinct when we compare that with respect to a wave refinement surface in a tide dominated estuarine setting. And when we are comparing this tide dominated estuary with a wave dominated estuary, the distribution of the facies types, the nature of the depositional systems above and below these surfaces are completely different. Say for example, over here, if I look at over here in this wave refinement surface, what we expect below this wave refinement surface, which is an erosional surface, below this what we expect, normally the shore face deposits will be present, and above this what we expect, some tidal bars, and these bars will start with some lag deposits, some erosional lags, which you commonly call as the transgressive lag deposits. If I look at over here in this part, definitely the tidal refinement surface in terms of its facies distribution, it will be different, because below this what we expect, commonly the bars which are formed by the rivers, and they are now truncated by tidal currents, and on that we are getting tidal bars where we can get some tidal bundles preserved within the successions. Again we can expect some transgressive lag deposits on the surface. So, in the wave dominated estuary setting, tidal refinement surface was distinct as the underlying unit was very fine grained deposit, as it was the central estuary deposit. In this case, we are not getting that fine deposits, but in terms of tidal influence, we can distinguish them very easily. So, tidal and wave refinement surfaces, they are distinct surfaces, they form at different parts during this transgressive phase, depending on which one is more dominant, how much is the dominance, how much is the energy condition of the corresponding tidal current and the wave energy condition. So, this scenario is applicable, is possible only when we assume that the rate of aggradation of the estuary mouth complex is relatively higher than the rate of subsequent wave refinement erosion or tidal refinement erosion. Because if the wave refinement surface, it develops at higher rate, that means when the wave refinement process is going on at higher rate, then definitely the background sediments, the landward sediments, they will get more eroded, and that will eventually rework the tidal refinement surface. In such cases, these two contacts would be superimposed. So, if I just go back to this diagram, so say for example, when this surface is forming, if I want to make a log across this, so if I want to understand how they are forming, say if this is the section, so somewhere here wave refinement process is going on, and somewhere in this part the tidal refinement process is going on in the same estuary. If more sediments are coming in and covering up over here, then only this surface will be preserved, because by the time wave refinement process will come over here, this is onlapping. So, at that time the refinement process will be going on somewhere here. So, always in a vertical log, if that extra amount of buffer sediment has got deposited, always in the vertical log we will get the tidal refinement surface at the bottom part, followed by a package of sediments, followed by the wave refinement surface. But if the wave refinement is drastic, is going on at very high rate, or the amount of sediment supplied in between this tidal refinement and wave refinement is not sufficient enough, in that case what will happen? Wave refinement will remove these sediments and this will merge with the tidal refinement system. Since wave refinement surface is forming at a later phase, it will overprint the tidal refinement surface. Same is the case for wave dominated estuary. In those cases, what will happen? If the wave system gradually moves in, say for example, it comes over here, it comes over here, so the tidal refinement surface will be gradually overprinted by the wave refinement surface. So, what is required here? Again we will get the tidal refinement surface at the bottom, and followed by that some deposit should definitely form, maybe the lagunal deposit, maybe the tidal channels, and on that we can get the wave refinement surface. Maybe over here we can get the beach sediments, the mouth bars will form over here, and then we will get the wave refinement surface. So, that buffer sedimentation is required for the preservation of both of these surfaces. Otherwise, wave refinement surface will overprint the earlier formed tidal refinement surfaces. So, with this I will conclude over here. So, in this class we have tried to understand what are the meaning of refinement surfaces, what do we mean by transgressive refinement surface, what are the different types of transgressive refinement surface. So, it can be wave or tide dominated refinement surface, accordingly we give the name wave refinement surface or tide refinement surface. So, these surfaces will be commonly identified in the marginal marine part, and the underlying and overlying facies types can vary significantly. So, we have tried to take an example of wave dominated estuary and tide dominated estuary to compare between how these surfaces can form in different parts of the basin, in different parts of the environment, and what are the resultant overlying and underlying facies types or depositional systems with respect to those surfaces. So, we will continue this lecture in our next one also, and there we will discuss about the further aspects of the transgressive refinement surfaces. So, these are some of the references that you can follow for further study. Thank you everyone.